This time I got a Sony clock radio model EZ2. This is a vacuum fluorescent display clock radio that Sony had, about 40 years ago, I guess. This one's kind of unique because you can just dial your wake-up time. It has two knobs on the front for the hour and minute setting. And this one has a dim display. So we're going to see whether it's a display or whether it's another component that's causing it. I had this little Sony clock radio shipped in. This one's called an EZ2. Or Americans would call it an EZ2. We call it an EZ2 here in Canada because of, well, it's Z, not Z here. But EZ2 is what they called it in the States. And probably most people called it that here as well. This one here is one that you can set the alarm very simple by just pressing a button and turning the alarm. You set it to what time you want. So say you want to wake up at 7 in the morning. You set it to 7 o'clock and then turn on the alarm and it would set it for 7 a.m. Or if you want 7:30, dial in 7:30. Right? Made setting the time very easy. In fact, I used to have one just like this. Mine was all white. I bought it for my then significant other, who is still my significant other when she was young, when she was living at her parents' place, and I bought this for her birthday, I think 1 year. And I don't know whatever happened to it. It might still be kicking around somewhere. I think it broke, but it might still be kicking around somewhere. Anyway, this one here, the display is quite dim. So the fellow that sent me this, he wanted to know whether we're able to brighten the display up at all. It's more than likely the display tube is getting weak. As you can see, the auto dimmer still dims it down. It's just that it's really dim, like even in the bright light. It's more than likely the display, but we'll check it out and see if any of the voltages are off, and perhaps, maybe, just maybe, we can get this one a little bit brighter. So let's take this one apart and take a look at the inner workings. Almost looks like there's no screw in that one. That screw's missing. I only took two out and there's already one missing. I forget how this comes apart. I think these knobs have to come off because the whole radio is going to lift out from here. Pretty sure these knobs just pop off carefully. Of course. And they are keyed. Okay, good. Just making sure that they were keyed so that they only go back in the one way, which they are. They're both keyed. Okay. Alright, now this unit should lift apart. The top should lift off, or the bottom, or whatever comes apart on this. I think the top lifts off on it, if I remember. Oh, one more screw. Another warm day here today in the workshop. And there is the unit itself. Here's our display board up front here, and the radio in the back. And the power supply, of course. Complete with that wonderful glue that goes conductive after a while. We can see it around this diode and these wires. It will actually corrode those wires if it's given enough time. It'll eat right through the insulation and take the wire out. This stuff's horrible. So we're going to try to get this glue away from this wire so it doesn't short anything out, and actually try to take the glue away from that diode as well, just so it doesn't short anything out there. Okay, so it's not going to short now. It's not on both conductors, it's just on one. Going to pull the circuit board out that holds the radio in place, or the I'll pull the display board out just so that I can take a look at the board itself and see if there's any problem with that, if there's any of that circuit glue on there, and we can check some voltages out and see that the correct voltage is getting to the display tube. It's very likely it's just a display tube, but we might be able to crank it up depending if we've got any reserve. Display should lift out now. There we go. Okay. Now I have the clock display out. First thing I'm going to do is I'm going to remove this residue from this sticky tape that was on here, because like the circuit glue, the adhesive has a tendency to go conductive when it deteriorates and cause shorts on the various components that it's covering. So let's get this out of here first, and then we'll see where the photocell, or light dependent resistor, sometimes they call it, CDS cell, is connected. It's connected up over here, which goes to a couple pins on this header, which goes right across over to this side. There's just a wire header that goes under the display. If you look carefully, you can probably see it. See the wire header here that goes underneath the display and connects over to this. So this should be carrying all the signals from this side right over to here. More circuit glue in here. Alongside of this switch, there's some circuit glue here. We'll just get this out of here just in case it's shorting something, because that's right in the vicinity where that jumper wire goes. Right into here. That might just be on a mounting tab, so I might be okay with that. Yeah, I think that's just on a mounting tab for the switch here. These are the two pins that the CDS cell connects to. One goes to here, the other one goes to there. But I don't know where they go from there because I can't see it. It's underneath this switch. So it likely goes to another jumper. To figure out where it goes and what it is signaling. This one likely goes over to here. I don't know where this one goes. So I've checked the voltages going to the tube, and this is what they call low voltage vacuum fluorescent display, so it does not have high voltages. Some of them operate in like the 30 to 60 volt range, but this one here actually operates at much lower voltages than that. And that's evident because the capacitors in the power supply are only rated at like 10 volts. So there's no high voltage caps on this one here. You can see this 16 volt, 10 volt. What's this one here? 10 volt, 10 volt. These are all 10 volt and 16 volt capacitors. Right, 10 microfarad, 16 volts. 10 microfarad, 16 volts. They're all low voltage, every single one of them. So we know that the power supply is only capable of putting out low voltages. And we do have correct voltages on the back here. If I measure the different voltages on the back of the supply, they're all within range. If we look at, for example, if we look at the filament voltage, well, we won't get there yet. This is the display voltage for dimming. This one here will actually change when you cover up the sensor. You see, it goes up to 8 volts to dim it down, 7 volts to brighten it, and got 7 volt supply. VSS is 4 volts. This is filament, and B plus 7.58. So I've now disconnected the automatic dimming. As you can see, the display does not dim when I cover up the sensor. It's now on maximum brightness. And there's no way to get any more brightness out of this. The display actually isn't as dim as it looks, but because it's got a dark blue lens over it, that cuts down a lot of the light. It's pretty bright in here too. But anyway, even with the circuit disconnected that dims it, the light is still not that bright. So this is a clock that I built a couple of years ago. And if you notice on here, one of the display tubes is really dark. Right? This one uses individual tubes. This is what happens with these vacuum fluorescent displays. Now these are all the same age, but you can see one's aged a lot quicker than the other, and it is the display, because I do have another display that I can plug on this. I have the six digit 15 or 14 segment alphanumeric that plugs onto the same module, and that display works fine. So it's not a problem with the circuitry, it's a problem with this one display tube. And that's what's happened on here. This display tube itself, it's just gotten tired. They're a vacuum tube. The filament, which is a hot cathode filament, emits electrons. And eventually the coating that's on the filament wire, which is a tungsten wire that's just kept warm, but the coating that emits electrons through thermionic emission just gets weak and stops emitting electrons. And that's what happens on these old vacuum tubes. Some of them will last 40 years, other ones might only last a year or two. It really depends. It's the luck of the draw. To fix this one, I'm going to have to order another display tube and change this one display in order to get this one working back like it used to. But that's the problem with them. It's the display tube that's gone bad. No amount of tweaking or anything that I can do to this thing is going to make it any brighter than it is. Even if I were to increase the voltage on the filament, that would just be a very short-term fix, and we'd be right back here very quick. And I know some people have said, well, we'll just increase the voltage across the filament just to give it more voltage, which will make it hotter. And when it's hotter, it will emit more electrons. Yes, that's true, it will. But it's a very short-term fix. It only typically works for, in some cases, a couple of hours to maybe a month or so. And then you're right back where you started. It's going to get dim again. Unfortunately, the only way to fix this one is to source a new display. So basically, I'm just going to throw this one back together and send it back where it came, as there's not a heck of a lot that I can do on this as it sits. It's got a bad display. It is quite a unique piece though, just the way that the clock is set on this. There wasn't too many like this. In fact, I think this is probably one of the only ones I've seen that's like this. It's actually relatively easy to service as well, because everything just pops apart just like that. And then the dials just go on. There's only one way they go on because they are keyed. There you go, back together. Still working, but dim. But not much I can do. Alright, thanks for watching. We'll catch you in the next one.